started. Go. Hi, and welcome to this MindShift Challenge. I'm sorry about the delay. We had a few technical problems, but this is a NASA Google Plus Hangout with Edison Nation. I'm Chris Rink from the Communications Office here at NASA's Langley Research Center in Hampton, Virginia. MindShift is a training and entertainment technology that mimics reality. Edison Nation is an open innovation online service. We'll talk more about the relationship between the two in a few minutes, but first I'd like to introduce the inventors of the MindShift technology, and sitting to my left is Alan Pope. Alan is a senior research scientist in the Crew Systems branch at NASA Langley's Research Directorate. We also have Chad Stevens, another research scientist. He's from the same branch and directorate at Langley. Before we talk more about the MindShift technology and Edison Nation, let's go to Dan Lockney, NASA's Technology Transfer Program Executive, who is visiting us, the Jet Propulsion Lab in Pasadena, California this week. Dan?
Hi, thanks, Chris. We're really excited about this partnership with MindShift. A little background on NASA Technology Transfer. We've been doing this for the 50-plus years that NASA's been around. And the basic concept is NASA develops new technologies, new solutions for complex challenges. And then we try to find ways that these solutions that we build for our mission needs can be translated to terrestrial and practical benefits. We try to get the technologies into hands of industry and into the hands of the everyday users. So we develop something for one of our mission uses, but we're not always sure who else can use it. So we work with groups like Edison Nation to see if we can help have them help us tap the cognitive surplus that's out in the internet and out in the ether, and see if other people can come up with applications for our technologies and tell us how else they can be used. So we're looking forward to this hangout. Really looking forward to the partnership with Edison Nation bearing some fruit, and looking forward to today. Thanks so much.
Thanks, Dan. Let's not forget our other participants in today's Google Plus Hangout, and that would be you, the viewers. If you have questions about MindShift or submitting ideas for potential uses of this technology with Edison Nation or NASA's Technology Transfer Program, you can submit your questions via this chat page, well, actually via the Google Plus page, YouTube, and also Twitter. That would be #AskNASA. You can also submit questions through the NASA Langley Research Center Facebook page. We started a thread this morning to take your questions as well. And we want you to learn more about MindShift on this Google Plus Hangout today. And NASA and our Edison Nation partners value the importance of intellectual property, so we want to advise you that your questions or chat room posts should be written so you are not exposing any specific potential uses of the MindShift technology. This approach will ensure that the potential path to intellectual property is intact for you and your concepts. In other words, try not to be too specific in your questions about how you're going to use the technology. You can always contact it after the Hangout to go into that in a little more detail. So let's get started and just get a little background on MindShift. What is it?
Well, as you said, Chris, it's both an entertainment technology and a training technology. It's entertainment in that it can be interfaced with video games, off-the-shelf video games. And it's training in that it requires the user, the player of the video game, for instance, to produce particular physiological signals and learn to produce those that can be beneficial to their dealing with stress and their dealing with attention problems.
It's physicians hoping to manage children's attention deficit or hyperactivity disorders have studied MindShift, some with good results. Can you talk about this and some of the other medical applications?
Well, in the past, this has been subjected to a experimental study at Eastern Virginia Medical School, and it was found that the version of MindShift that works with the PlayStation 2 years ago was beneficial in alleviating the symptoms of attention deficit disorder in children. MindShift itself is a concept that cuts across several platforms, not just the PlayStation. Currently, we have it on platforms like the Wii or the Microsoft Kinect system.
Well, now, the MindShift technology is getting a little push, and the push is coming from Edison Nation. And we have a partnership with them, and I was wondering if you chat and talk about that.
So we're really excited about this opportunity. This is our first sort of exposure to open innovation, which is really great because what it's going to allow is for innovators across the country to submit their proposals about how would they like to use MindShift in new technologies, in new ways, and really expand the capabilities. So far it's been limited to the 3 co-inventors of the MindShift. And so we only have so many ideas about where it can be used. But all of these inventors across the country can really probably come up with a lot better ideas than we can.
And people are coming up with questions. Actually, we had some submitted on the Google Plus site before we got started today. A little late, sorry, but we still got started. And one of the first ones, and we did submit the answer online, is what competitive edges do you feel MindShift has on existing BCI products, such as the Mattel MindFlex and Emotive Epoch, that an inventor could exploit? Question mark. Also, what would be a reasonable low and high price range to shoot for?
So the BCI products, or the brain-computer interface products that I mentioned there, we actually try to extend the capabilities of those existing products. So we try to take those types of devices, incorporate them into existing prototypes that demonstrate the capability, and then add a little bit more functionality to them. And that's what MindShift really does, is it takes the ability of those brain-computer interface devices to record brainwaves and then add the training effect to that capability.
Well, I'm not seeing any questions in our Q&A box, so just as a reminder, you can submit your questions via hashtag AskNASA, our NASA Langley Facebook page, and through this Google Plus page, and also at YouTube if you're watching and find it. Alan, I read in another interview that you were one of the first researchers to talk about computer games as a form of, I've never heard this word before, cyber therapy. Do you still feel there's a big potential for this?
Well, I think so. Not just the kinds of computer games that we have working with MindShift, but computer games are starting to be recognized as benefiting things like spatial abilities, those kinds of things, by other researchers. MindShift is unique in that it embeds biofeedback into video games. And by biofeedback, I don't simply mean brainwave biofeedback or neurofeedback. I mean any kind of physiological signal that you can sense with off-the-shelf modern technology. The MindShift module, you can think of, it goes between that technology and a video game or a training task simulation for that matter, and causes it to reinforce a person's production of beneficial and helpful physiological signals.
I'm going to talk to you more about that later. But we had a question in from Twitter. David Barry says, I believe that's what Hertz channels does MindShift access?
Well, there are several versions of MindShift. And as I said before, it uses off-the-shelf brainwave devices, and those access alpha waves, beta waves, those kinds of things. And what MindShift does is it adds to that. It actually interfaces between an off-the-shelf headset that picks up brainwaves and all those bands, and interfaces that with a video game. It causes the video game to reinforce production of particular beneficial activity. In brainwave activity, if you wanted to relax or develop a calm and collected ability, then that would probably be alpha brainwave activity that we would reinforce. We would have the game respond in such a way that it did better if you were producing more alpha activity. If you wanted to learn to focus and concentrate, it would then pick up brainwaves it would then use brainwaves that are more associated with attention and concentration, like beta activity, and use that to influence the game.
We have more questions from Twitter. Adam Wild writes, can you offer a few insights into what MindShift can't do?
I can try to answer that one. That's a tough question. Essentially, what it can't do is immediately result in someone having a drastic change in their ability to control their physiology. What it does is going to have effects very gradually. So that's typical of all biofeedback devices and neurofeedback devices. So we're not talking about changing someone's state immediately and having a lasting effect. What we're doing is we're starting a training process that with time can allow someone to shift their mental state based on the physiological signals that are being incorporated into the MindShift system design, so that eventually they would have a calmer state, if that's the goal, or a more focused state, if that's the goal. So it's not that we're trying to have this immediate change, but it's a training system that allows for gradual and healthy change. Also, just to dispel any potential confusion, it's definitely not reading anyone's mind. We're not making that claim. What we're saying is that we're able to identify these specific signals that relate to general mental states, and then we allow someone to select the mental state that they'd like to achieve and work towards that goal in a training context.
And in that way, since it uses biofeedback, which is a fairly well established modality of training, it's a lot like exercise. It takes time to acquire the skill that you're trying to acquire with biofeedback or neurofeedback. It's not an immediate kind of thing. And that has been one of the problems with biofeedback training, is that it does take time. It takes several sessions to acquire the skill to control a physiological signal. And so what we did was embed that kind of training into an entertaining medium, like video games, so that a person is both fed back the information about their physiological signals, but they're also rewarded or reinforced by the entertainment value of the game to continue to practice. That's necessary in anything, even when you're exercising. Sometimes you can think of sports as being a way to exercise in a fun and entertaining way, and we kind of borrowed that concept with MindShift.
What is very popular today. How much would you expect someone to pay for the MindShift hardware, if that's possible at this point? Because I do understand that whoever licenses the technology eventually will have to go through a process with you, with NASA, and then eventually, before they even start manufacturing and marketing or getting something on the shelf.
That's a good question. We don't really want to set any hard and fast limits. But typical consumer-grade capabilities like this are equivalent to what someone would pay for a Microsoft Kinect, possibly. The hardware and the software doesn't have to be extremely sophisticated, so that helps to limit the cost. And so, on the order of a device that someone would use with a typical video game system is probably a good price range. Microsoft Kinect, I think, goes for around $300 now. So that's, what we're thinking. But it might be possible to have devices that are much less than that.
And when a company does license this and pick it up and put it on the shelves as a product, it would be more sophisticated than our prototypes are. Our prototypes demonstrate the concept, but they're not the ultimate embodiment of MindShift. And we try to get by as cheaply as we can with those, because we don't want NASA to invest great funds of money in this kind of thing. But someone could probably, well, no doubt, build better versions than our prototype, something that's more user-friendly and consumer-grade.
Here's a good question for Edison Nation, if you can answer this. What can submitters do to improve their submissions to the Edison Nation MindShift Challenge, and what shouldn't they do? And, if that's something, we can always try to go to Edison Nation and see if they're available. Scott Dromms from Edison Nation is standing by. Scott, can you answer that?
Chris, can you go ahead and repeat that question real quick?
Sure. As what can submitters do to improve their submissions to the Edison Nation MindShift Challenge, and what shouldn't they do?
I think one of the key things we're looking at is really understanding, and Chad gave a great example of this is more of kind of a muscle memory type approach, but it's the physiological version of exercise equipment. So I think we're really looking for individuals to have done the research about what the MindShift technology is capable of doing, and really understanding what are aspects of their everyday life. It's a great example. Chad and Alan mentioned it's three inventors of this, and their ideas are gonna be broad, but not as broad as we want. So we want regular individuals to figure out what is it in life that they think that having better control of physiological actions in their body, their heart rate, other measurements, can help them perform a daily task better. So I think a lot of it is really just thinking about what things you think you can perform better, that you may have anxiety about, that you may have challenges with. I think that's really kind of the key, and I would agree with what Chad mentioned as well. We don't want to. I wouldn't pigeonhole yourself into a price point of where something can be, because this really has a lot of different potential avenues that the MindShift technology can be embedded into. There may be some very simple consumer products, but there also may be things within the medical world as well that I wouldn't get too hung up on what the final price may be, Chris. That's one consideration I would give as well.
Okay. Another question is, what wearable hardware can be used with MindShift? I know that I know that you using off-the-shelf for the prototype right now, but what do you think?
So the BCI systems that were mentioned in the previous question are examples of consumer-grade monitoring capabilities. Those are some wearable technologies that monitor brain waves. Heart rate monitors that are typically used for sports activities are another example of physiological monitoring that's very consumer-friendly, ready to use off the shelf, that could be incorporated into a version of the MindShift. Other measures that might be of interest to be trained could be something like respiration. We think that respiration is a very simple signal, but it has a great impact on our ability to relax and achieve calm. And so incorporating a respiration sensor into this type of technology could be very interesting and very worthwhile for the user. So I think those kinds of signals are the most apparent. But we have a prototype that uses the Microsoft Kinect. The new version of the Kinect actually allows for monitoring heart rate with a camera-based system unobtrusively, so they wouldn't even need to wear any sensors at all. They would just step in front of the Kinect, start to play their game, and then the MindShift capability would kick into effect and start to help them train their heart rate. And so specific expectations that we have, because that's only gotten us so far, and so the open innovation hopefully will enlighten us of several or many more possibilities and sensors that could be used with MindShift.
To add to that, Chris, every day when we scan the internet, we see new technology, new wearable technology coming out. I saw one just this morning from the MIT Technology magazine that monitors heart rate and maybe some other signals from something in the ear, like an earbud. And a couple of the companies that we work with have started putting out wearable versions, small miniaturized versions of their pretty sophisticated EEG technology. So the front end is expanding. It's really blossoming out there. The kinds of front ends that you could use with MindShift would then go between that front end and some kind of task or some kind of activity that you were interacting with on the computer, or in the case of one of our inventions, a physical practice golf device.
We'll talk about golf a little later on, but following up when you said a 2013 New York Times article mentioned that the brain-computer interfaces were getting closer to mainstream with wearable computers like Google Glass and more. So, following in on MindShift, do you have any predictions about within the next few years that it's going to be as commonplace as a smartphone? Or?
Oh yes, I think there'll be more wearables, and also related to what Chad was saying, there'll be sensing that's not even contact sensing with the neck sense heart rate. And we authored an article a few years ago called Morphing Beyond Recognition about biofeedback, and it said that even the walls of where you are will eventually be able to pick up physiological signals remotely, and that can be used in conjunction with MindShift.
So, in other words, if you've had a stressful day, you walk in, your house computer is going to do a scan of you and ask you if should I turn the temperature down, maybe turn the lights down, put on some nice music or something like that.
That's very well be true. Yeah.
Okay, I'm not trying to give out too many ideas for the viewers for the Edison Nation. Consider it a freebie. Angela Gibson on Twitter asked, do you have any information for K through 12 teachers and informal educators?
Well, I can refer back to the study that was done locally here at Eastern Virginia Medical School, where the first embodiment of MindShift, the PlayStation platform-based MindShift, was studied with children with attention deficit disorder. Now, that's not a new application for brainwave biofeedback. There is a lot of activity going on in applying brainwave biofeedback to the treatment of attention deficit disorder. What we did in that study was compare the MindShift technology, which is video game-based, with all conventional brainwave biofeedback technology. And it was found that the differences in improvement were the same between the two technologies. The difference was that the children in the study were much more willing to come to practice, come to training, than they were in the group that was using the video game technology.
I can't imagine why.
And to add to that, I know I have family members that are educators, and Alan does too as well. And well, a lot of times we think about how could this technology assist the educators in the classroom when they're interfacing with a large group of students or individual students. And we would be very interested in ideas, involving monitoring, the students while they're doing the learning activity and giving feedback to the educator to say, it seems like this student's not really fully focused, so maybe reiterate some information to that student to help them improve their learning experience. And so that's an example of how educators might be able to take advantage of this technology and really run with it and greatly improve the educational process.
Following up, Angela, again, on the MindShift program, she was wondering if any studies, the program had any studies with children with disabilities or used with metronome treatments.
It hasn't been compared to that form of treatment. I know that's been studied by others. I should also point out that, as Chad mentioned, in the classroom, a lot of instruction is being delivered by computer, educational exercises on computers, and MindShift is ideal for interfacing the child's feelings, emotions, and attention, and cognitions with these forms of teaching tasks, instructional tasks on computers. MindShift would be the module that went between the sensing technology, which would probably be wearable, and the the instructional material on the screen, and modify that material to match the learner's current attention level, their current stress level, maybe how they're progressing through the lesson.
Adam Wilde writes again, which brain waves does MindShift recognize? For example, alpha, theta, etc.
So Alan mentioned some examples of the specific frequency bands of interest when you're using EEG. Alpha being indicative of relaxation, so if the MindShift were designed in such a way to try to train up relaxation, then alpha would be the focus. If we wanted to try to entrain concentration, then we would say that beta is the brainwave that's of interest and to be uptrained. So those are the sort of general ideas. The literature also tells us that using combinations of brainwave frequencies can be informative and helpful as well, and can be trained simultaneously and to have great effect. But those are just sort of the way we see things. We're hoping that the innovators out there that are applying to the Edison Nation partnership opportunity are able to come up with even more novel ideas or more novel approaches. Combining brain waves with heart rate activity, with respiration, with other types of signals to make the training system even better, or really make it more entertaining to play a game or interact with a computer interface.
This question has been submitted on a few different ways, and that is, can the MindShift technology, hardware or software, can it detect pain in the brain?
That would depend upon the physiological sensing system that you're using. Usually brainwave measures are not used for that. I guess to go off on a little bit of a tangent, there is one researcher, Christopher Dromms, who has used fMRI, which you call it neurofeedback. It picks up the signal from the pain center of the brain and feeds that back, in this case, in the form of a flame that rises and falls with pain level, and it's shown that that can help someone alleviate chronic pain problems. fMRI is probably not a convenient sensing technology to use with MindShift, but MindShift, this gives me an opportunity to point out that MindShift is independent of the kind of physiological signals that are fed into it. MindShift is the interface between those signals and the task or game or simulation or whatever that you're interacting with on the screen. So if that kind of a pain signal is identified by other researchers, that could be fed into MindShift, and the person could learn to reduce that pain signal.
This is interesting. Actually, you could consider it a comment and a question. In the near future, will we have MindShift gyms in school?
So it's a very interesting question. Actually, last summer, we tried to instantiate a brain gym here at Langley, and it was successful. We had 20 NASA Langley researchers and other employees come to this training capability and use it on a regular basis for about 8 weeks, and they were training using neurofeedback. And so even some of them mentioned, this is just like going to the fitness center, except I don't get all sweaty. I just sit in a chair and sort of engage with this task, and it really helps me to become more focused and hopefully become more innovative, because that was the goal of the study. So that's definitely a possibility that we'd be interested in.
Is MindShift space hardened? Can it be used to record data in space? Or at least does it have the potential to be used on the space station or other exploration vehicles?
Again, that depends on the hardware that's implemented by a potential licensee. Already, of course, physiological measurement, physiological technology is on orbit, the space station, and in the shuttle at times. So that kind of technology exists. What MindShift would add to that, and that's the theme of a paper, kind of a proposal paper that we wrote a few years ago. It would allow astronauts in space travel to interact with entertaining activities and at the same time be trained in physiological self-regulation, is what we call it, self-regulation. And that would serve two purposes. It would give them an entertaining activity, which are welcome on orbit, and it would also train them in physiological self-regulation skills to deal with stress, to deal better with stress. They already deal with stress pretty well compared to the rest of us. To deal with to better deal with stress and to be able to focus on tasks. So that aspect of that dual aspect of entertainment and training would work well in space travel.
Does MindShift differentiate between the different senses? It's a question that came in.
That is an interesting question. It's probably an innovation, actually. Let's say that we were to work with someone to design a system that focused only on visual information. Then we could probably discern from the signals that are part of the MindShift technology whether or not the individual is paying attention to the visual information, whether it's attractive or is drawing in their attention, or whether it's boring. And then the same could be applied to other modalities, auditory, gustatory, all types of senses could be potentially stimulated, and then the effect on the signals could be monitored, and then the experience could be changed. And that's essentially what the MindShift is designed to do, is to change your experience and have a training effect, or have a more entertaining effect, potentially.
Now, I understand it can be used with several physiological signal measuring devices for heart rate, muscle tension, brainwave activity. Are the devices something different from the headpiece? When you make the reference to the devices? I mean, it would be something that would go around your forearm or something else?
It could. If you search the internet, you'll find all kinds of wearable, what we call physiological front ends, where the signals are actually sensed and picked up. So it could work with any kind of technology like that, sensing technology. What we can say is that if you give us a signal, we can input it into MindShift and create a training and entertaining experience for you.
One of the questions that came in was wondering if you could do a MindShift demonstration. I know that we can't do it, but there is some video available on the Edison Nation site, and actually it was on the Google Plus site, so you can see some of that video to kind of give you an idea about how it operates, and with the amount of information we're providing today, I think you should be able to figure it out. But and again, going back to signal measuring devices and for stress, that sort of thing. What about the possibility of recognizing tension in a person's voice as a biofeedback, either for the technology or gaming technology?
Chris, I think you're one of the innovators today, because that's a really interesting idea, and this is a perfect example of something that I don't think we've really given a lot of thought to. We've talked about voice stress analysis as a measure, but that could be a signal that could be focused on, and then feedback could be provided about the person's state based on voice stress analysis. So that's another modality that we had never really thought very deeply about.
So potential law enforcement application then?
It could be. It could be that, if police officers or military or security forces are trying to remain calm in a very stressful situation, they could train heart rate activity, they could train respiration, but then if they have to be giving verbal instructions throughout a stressful situation, then it could be monitored while they practice doing these verbal commands or instructions, and then fed back to them about how stressed are they really becoming during that situation. So that's definitely a possibility.
Going back to the different platforms that you mentioned earlier, now it's just not with hardware gaming systems, but also with the full body recognition device like Connect.
Mm-hmm.
Okay. And do you think that there are health benefits associated with MindShift? I should say, when I see my nephews playing with video games, they don't necessarily seem relaxed. But and I know we're trying to reduce the stress so we can focus more. But is there a potential for health benefits?
Well, that's one of the questions that we get a lot about video games in particular. that this would encourage the use of video games, and people bring up concerns about being addicted to video games and the lack of activity and exercise with video games. The idea behind MindShift is to ask someone or require someone to produce healthful signals, brainwave signals or other body signals like heart rate, other stress measures. And if they're not producing those signals, if they're not producing brainwave signals that indicate that they can focus, if they're not producing physiological signals that indicate that they are calm and relaxed, for example, then the game does not function as well. So if a person was responding to a MindShift modulated video game the way they typically respond to a video game, in other words, getting stressed out or becoming zoned out, then the MindShift technology specifically makes the video game not as rewarding, and they are rewarded for getting out of those states.
Can MindShift be plugged into a cell? This is from Facebook. Can MindShift be plugged into a cell phone or a tablet for use with an app?
We hope so.
Yeah, we see this as a great potential innovation for this concept. The consumer-grade technologies like the NeuroSky MindWave that we've used have apps, mobile apps that work on cell phones and tablets already for more brain control interface, brain-computer interface types of applications. But we haven't seen any that are using this, the concept of the MindShift, where it's training or modulating someone's interaction with a mobile application. So that would be an example of a potential innovation. And it could be used in a wide variety of ways. So hopefully the open innovation will zero in on a couple of very successful, maybe at the level of Angry Birds would be nice, successful ways that MindShift could be incorporated into a mobile app.
And brings back that whole question about reducing stress that I just had, getting with Angry Birds. So are there plans to extend MindShift's current capability to other platforms?
We would hope that would happen with companies that would license MindShift. What we've done is develop demonstration prototypes to demonstrate the concept. And this, at the risk of sounding like a broken record, I want to emphasize that MindShift is not the sensing technology, not the video game technology. It's a thing in between those two. And what it specifically does is cause those physiological signals, waves or whatever, to influence the game so that you're playing the game with your hands, as you usually do, is improved if you produce particular physiological signals. And so that's the core of the idea. We call it physiological modulation. You're modulating the video game, for example, not directly controlling it. You know, folks may be aware of brain-computer interfaces where there's an attempt to use the brainwave activity alone without your hands being involved at all. Your hands are in your lap to control devices. That's not what MindShift does. MindShift also does not, well, that goes without saying, it's not just playing a video game. It actually modulates or increases the playability of a video game based upon your physiological activity.
Possible applications include use with third-generation video game systems. So I'm either showing my status as a digital immigrant or I'm just an old guy, but what is a third-generation system and how would it work?
Well, that's the digital native.
Okay. Okay.
So I think third-generation systems would include the Xbox One, the PlayStation 4, the Wii U, or I guess modern-day PC-based games such as Steam games or other digitally accessed video games. But yes, we're definitely interested in the possibility that an innovator could develop a third-party kind of device that would interface with the Kinect, or interface with the PlayStation 4, or interface with the Wii U, or interface with modern computers to allow for the video games to be influenced or modulated by the MindShift system. So it's not that the MindShift is only works with first, second generation video game consoles, or only works with PC-based games. The concept really is very flexible and can be fitted to even the yet to be seen fifth generation video game capabilities. So we'll see if the open innovation will really open that up, and make it a possibility for us to see be developed, and hopefully for everyone else around the world to see as being developed.
And the prototypes that we've developed have worked, as I said, with the PlayStation, the Wii, the Microsoft Kinect kinds of games. And you can find out how they actually work with those systems by going to the patent office, the U.S. Patent and Trademark Office, and looking at the patents and the patent applications that have been published. There are a couple that haven't been published, but should be out in the next 2 or 3 months, to find out exactly how we implemented the idea of physiologically modulating video games or simulations. But it could very well be that someone could come up with a totally different patentable way of doing that kind of modulation that is something that we haven't thought of.
Speaking of thirds, there are third-party, as I understand it, third-party video game peripherals for MindShift. What are they?
So that would be an example of someone augmenting let's take for example a Wii video game system with an additional component. Usually you'll see these in the form of some kind of new controller or with a different form factor, or improving the ability of the Wii to track someone, or just extending the battery life of the capability. So that's typically what we see in console-based video games when third parties create these peripherals. And so we really do see the possibility of putting the MindShift into this kind of third-party peripheral and being developed that way, because then it would be essentially totally hardware-based. The software would remain the same, so the game would still be the same, but it would be changed by the MindShift experience. So that would be how a third-party peripheral, one way that a third-party peripheral could embody the MindShift and allow for the use of the system.
I'd like to remind people that are joining us today that you can submit your questions about MindShift to this Google Plus site. If you're watching by YouTube, NASA Langley Facebook page, and also on Twitter, #AskNASA. And well, let's go back to the origins of the technology. It was part of the NASA Langley, as I read it, Intelligent Integrated Flight Deck Technology program. And the statement that you made, Alan, that you saw the relationship between the aircraft system and the pilot as analogous to that of horse and rider. And I like this, to quote you, the hazardous states of awareness, which almost sounds like an oxymoron. I mean, it would sound like if you're aware, then then you're not in one of the hazardous states.
It almost does. Actually, the analogy with the horse and the rider is the brainchild of some colleagues of ours, Ian Goodrich, Paul Shreve, Fred Flemish. The analogy that I came up with was the analogy of a flight simulator to a video game. And our core research measures, monitors physiological parameters of subjects in the flight simulator to try to determine what their experience is. Are they being bored? Are they being stressed out? We think of that as kind of a continuum from boredom to stress. And we try to determine then what about the design of that environment, the flight deck environment, is causing those extremes, and then change that and see if it improves any physiological measures. So at one point it occurred to me that it might be a good thing to try to feed back those signals into the simulator and adjust some aspect of the simulator. How much automation there was in the simulator. And so we conducted some experiments, which are in the literature, for that idea of a closed loop feeding back, in this case, brainwave activity to the simulator and adjusting the level of automation based on the level of engagement. And then I realized, well, that closed loop system could also apply to a video game, since video games are similar to simulators in that way. And that was the idea behind the spin-off, to actually transfer the idea of a closed loop into the video game area. And the key thing, and the thing that makes it different from other BCI applications, is that there are two inputs into the video game, just as there were two inputs into the flight simulator. Pilots controlling the flight simulator were, of course, using their hands to conduct the flight, but they also were influencing the level of automation with their brainwave activity. So that idea transfers directly into a video game, so that the control by a person handling the controller is influenced or made better or made worse based on their brainwave activity or other physiological activity.
This almost, I'm thinking this sounds like a silly question to me, but we have the existing technology, so is it a technical challenge to make the transition to something that could be on the consumer level, like MindShift?
I think it is a technical challenge. Here at NASA, in the core research, we try to develop technologies from the concept level up to a certain point, and that's usually around TRL level 8 or technical readiness level 8. And then it gets turned over to industry or to academia partnered with industry to build a further test article, and then take it all the way to real-world capability. So we sort of have an upper limit on how far can we really take a technology. And that's the same case for the MindShift, because this is a spin-off. We sort of have an even lower level of development that we're responsible for before it gets commercialized, and that process involves someone licensing the intellectual property and then developing it further and make it into a marketable product ready to go on the shelf. And so that is the technical challenge for the innovators that are out there working through Edison Nation, the partnership with Edison Nation, is how to put this into some consumer-ready version and then go through the process of manufacturing and marketing the product. So that's definitely a next step, and we hope that this opportunity will allow for us to be successful.
We've brought MindShift to several demonstration prototype levels, but the prototypes are not ready to go on the shelf and be sold. The idea is to make those into something that user-friendly, consumer-grade kind of electronics, and those prototypes are based on the patent applications and the patents that can easily be found and looked at. The ideas there, we don't think of them as brilliant, maybe clever a little bit, but they might stimulate someone to think of another way of doing the same thing that we tried to do.
Which is a good lead into the next question, and it's for you or Chad. There's lots of buzz lately about the autonomous car, driverless or self-driving car. How would you incorporate MindShift into a self-driving car? Again, not that we're ever stressed during rush hour or anything like that.
Yeah. So going back to the reference to the metaphor of horse and rider, and we do have to give credit to the originators of that idea, Paul Schutte, Ken Goodrich, and Frank Flemish, for coming up with the concept of a new vehicle that acts like a very intelligent form of transportation, a horse, and it is aware of the environment and doesn't make as many mistakes as a robot that just drives in a straight line, for example. The part of the autonomous car that MindShift could potentially contribute to would be to include or incorporate those stress levels or those inattentive measurements into the suite of sensors that a car already, non-autonomous, regular cars already have so much information coming into them. A couple more channels about the state of the operator would probably greatly improve the safety of an autonomous vehicle. And so how could that be modulated? If the operator has turned over control to the driverless or self-driving car, perhaps you should still be engaged with the task to some extent, and the modulation could occur by changing the volume of the radio in the car, or dimming the lights or brightening the lights of the instrument. So that's a couple of examples of how the modulation could occur and make the system or the vehicle system more intelligent and more in tune with the driver in real time.
And we thought about how that could also hark back to the original core research that MindShift spinoff came from, where the level of automation was adjusted according to whether the person was more or less engaged. So you could have a level of autonomy or level of automation in a vehicle like that to be responding to the person's state of attention, so that they would be protected from the effects of drifting off and that kind of thing.
Question came into our Google Plus site. Can MindShift control prosthetics? And actually made a comparison to RoboCop.
That's so that would be, if taken at face value, that would be an example of what's more commonly referred to as a brain-computer interface or a brain-machine interface. And there are technologies that exist to control prosthetics. Maybe an idea about how MindShift could be incorporated into that type of control is if someone is using a prosthetic hand that has some potential force that it can exert, and it's exerting that force on something that you don't want to break, and it's monitoring the attention of the user when they're grasping that object, and it detects inattention. Then it would sort of dampen the amount of force that could be inputted into that object so that it won't become damaged when the person is not paying attention anymore. Because in a prosthetic, well, what we typically think of as prosthetics, there's not a lot of feedback coming through that device. Now there are some brand new state-of-the-art prosthetics that do have feedback, but for those prosthetics that don't have force feedback, that can be a way to sort of limit damaging either objects that are being held or even damage the prosthetic itself. So that could be one way that this modulation capability could augment or improve prosthetic capabilities that already exist or that are still being developed to this day.
And RoboCop's strength could actually be modulated based on the anger of, who is it that inside RoboCop? I don't know the name. But to modulate the strength so that anger wouldn't result in a lot of destruction.
How's your golf game?
Cool.
Okay. But you had was it last year or the year before that you were working on a similar application to improving your golf game?
Yeah, a few years before that. The MindShift concept, as we've been pointing out, is very general, I guess you'd say. It doesn't necessarily have to apply to video games or computer tasks, that kind of thing. So there's one invention that's patented that can be looked up in the Patent and Trademark Office that involves sports, and it involves several different sports in the patent itself. But the prototype that we developed involved a office putting practice green, I guess you could call it, and it was based on, in our prototype, we were basing it on facial muscle tension or relaxation in the face. And as the person became more relaxed, the surface of the putting green, which initially was vibrating a great deal. We call it undulating, rocking back and forth, settle down so that they could make a putt. And the hole had an iris shutter that expanded and contracted and got wider when the person was relaxed, and also a laser sighting line that swung back and forth until the person became relaxed and the sighting line was still and gave them something to aim at. But I don't want to get into too much detail about my favorite things, but it's that's to make the point there that that's the mind shift concept, but in a different embodiment, in a very physical embodiment, not something in pixels.
Question came in by Twitter is, what is the cost to license MindShift?
We don't know exactly. I have been told by one of our former patent attorneys that folks would be surprised at how available NASA technologies are for license, how easily they can be licensed, how, I guess, cost-effective.
Affordable.
Affordable. That's the word I was looking for. As opposed to something that industry came up with.
Mm-hmm. We've been showing some photos during the presentation today. Heart rate and are heart rate and muscle tension changes detected with the same headset that have been shown in the photo?
They certainly could be. This headset is that we see in some of these photos is an off-the-shelf EEG-only headset. But the capability of adding heart rate detection to that headset is very, very possible. Also detecting muscle activity from a headset like that should be very possible. It's just that the maker of that device focused on EEG only, and we're grateful that they have produced that device because we get to use it in our prototypes. But it is very possible that it could record multiple signals at the same time.
And as I mentioned before, I just recently saw an earbud device that picked up heart rate, and that could certainly be added to that kind of headset. And these things are going to happen. They're probably not things that we will focus on, developing a more wearable physiological sensing devices, but we see improvements in that every day.
Interesting question. Could MindShift play a role in advancing your learning capability? How you possibly putting you in a physiological state where you're actually learning better?
Well, that was one of the ideas behind the study we did with attention deficit disorder. But it could probably be done in real time, so that as you are trying to learn material and instructional computer program, that your brainwave activity, or maybe some of the other physiological activity, that alter the speed or the rate at which that material is presented to you, it would reinforce you for becoming more focused while you were learning the actual subject matter material.
We have time for one more question. And could MindShift receive mechanical signals instead of physiological ones?
Yes. Yeah. So it would be possible for the user to operate some mechanical device, and then that be the signal of interest that the MindShift operates on or modulates based on. And then to make it even more sci-fi, we could use something like the Microsoft Kinect to measure the mechanics of someone's movement, and then that can be the signal that's being used to modulate the video game system in some way. So it doesn't have to be restricted to these sort of internal physiological processes like brain waves or heart electrical activity. It could be gestures, motion, interaction with physical objects, interaction with physical environments even, and how those things are being changed or manipulated by the user could then be processed in as a signal for modulation purposes.
Well, let's see where we are. Well, I think we're kind of at the end of our program here today, so I'd like to thank for today's MindShift Challenge, Google Plus Hangout, and I'd like to thank the inventors, Ellen Pope and Chad Stevens. And also there's a third inventor who didn't join us today, who is Nina Blanson, who from Austin, Texas. I'd like to thank Jennifer Budez from the Tech Transfer Office and also Scott Dromms from Edison Nation for helping out today. And also like to thank Dan Lockney, NASA's Technology Transfer Program Executive, for joining us at the top of the program. And thanks to all of you out there who've been watching today via this Google Plus Hangout or on YouTube, and for all of your questions, lots of good questions. How would you apply the MindShift technology into consumer products or applications? Again, NASA Langley is working with Edison Nation to take in your great ideas of how you put MindShift to work. The online search is open to your ideas until midnight on Monday, August 11th. To learn more or to submit your ideas, visit www.edisonnation.com/MindShift. And for more information about MindShift and NASA's other spin-off technologies, go to Technology Gateway, all one word, .nasa.gov. I'd like to invite all of our social media followers to join us the next time we host the Google Plus Hangout. Meanwhile, follow us at nasa.gov, Twitter, or Facebook. I'm Chris Rink. Thanks for joining us.